Hey, what's up? It's Jake from Novus DevOps, and we're going to go a little bit further down into the Kubernetes components by talking about nodes, pods, controllers, schedulers, and etcd. So I'm going to make this a short explanation of each so we don't get too long, but let's talk about nodes. So Kubernetes runs your workload by placing containers into pods to run on nodes. So let's take a look at our diagram here. So this is a node, this white rectangle here. And in here, I have a kubelet and a proxy, and there's a container runtime on here as well. But in here is where we run our application. And if you read further, it says a node may be a virtual or a physical machine depending on the cluster. So when you think of node, think of like a compute instance or an EC2 instance, right? Each node is managed by the control plane and contains the services necessary to run pods. So a node runs pods, okay, and it's managed by the control plane. Typically, you have several nodes in a cluster. In a learning or resource limited environment, you might only have one. So you'll hear like single node cluster or a multi-node cluster or a 5-node cluster or whatever. So a lot of people at home may build Kubernetes clusters on a Raspberry Pi. So in that case, your Raspberry Pi is your node and you have everything running on a single Raspberry Pi. Therefore, that is a single node cluster. So your control plane, your your worker node, it's all the same thing, right? Because it's a physical, in that case, a physical server. If you had two physical Raspberry Pis, you could have the control plane on one and the worker node on the same, and have a second node on the second Raspberry Pi and have them networked together. And that would be an example of a two-node cluster. It is also possible to have a control plane on one Raspberry Pi and then have four more Raspberry Pis that all are each a node, and each Pi would run pods on it, right? And that would be like a 5-node cluster, and with an isolated control plane. So that's what a node is. So let's look at pods. So a pod, and this is important, is the smallest deployable unit of compute that you can create and manage in Kubernetes. So as far as Kubernetes is concerned, a pod is as far down as you go. So a pod, as in a pod of whales or a pea pod, and came from the whole, if you go look at Docker and you look at their logo and they have the whale and you wonder why, well, that's kind of where all of that terminology comes from. But a pod is a group of one or more containers with a shared storage and network resources and a specification for how to run the containers. So I can have a pod, and in there I could have an Nginx container, or I could have an Nginx container and a database container. And the pod's contents are always co-located and co-scheduled and run in a shared context. So a pod models an application-specific logic host. It contains one or more application containers which are relatively tightly coupled. In a non-cloud context, applications executed on the same physical or virtual machine are analogous to cloud applications executed on the same logical host. As well as app containers, a pod can contain init containers that run during pod startup, and you can inject ephemeral containers for debugging if your clusters have that. But if you think about like the database and the web server, those should be loosely coupled, right? They should be separate. You should be able to scale them separately. The storage is separate, et cetera, et cetera. And since they're loosely coupled, you would not want those in the same pod. They should be in separate pods. And you could even have each of those pods on separate nodes. And so that's the whole idea behind that. Um, so that's what a pod is. And then let's talk about controllers. So I liked the explanation of this. It says that in robotics and automation, a control loop is a non-terminating loop that regulates the state of a system. And the example they give is a thermostat. So when you set the temperature, it tells the thermostat about your desired state, right? I want my house to be, 72 degrees or 68 degrees or whatever you want. The actual room temperature is the current state, and the thermostat acts to bring the current state closer to the desired state by turning equipment on and off, right? Turning your air conditioning on, turning your heater on. In Kubernetes, controllers are control loops that watch the state of your cluster and then make or change requests whenever they need to. and then each controller tries to move the cluster state closer to the desired state. So it's constantly just making sure it's the thermostat of your cluster, right? It's just making sure that their desired state is in fact what is happening. And if it's not happening, it tries to get it there as quickly as possible. Um, so yeah, and there's tons more documentation on this stuff, but I'm just going over the basics so you can understand what it is that we're doing. So when we deploy it and you start looking at things, you're not like, what is a controller? All right, and then there's the scheduler. So you might be wondering, well, what's the difference between a controller and a scheduler? So this refers to making sure that pods are matching to nodes so that kubelet can run them. So let's take a look at our diagram again. So the pod inside of here should match and be assigned to a node, and the kubelet will be responsible for making sure that that runs. So the overview of this, the scheduler watches for newly created pods that have no node assigned. For every pod that the scheduler discovers, the scheduler becomes responsible for finding the best node for that pod to run on. Okay, the scheduler reaches this placement decision taking into account the scheduling principles described below. If you want to understand why pods are placed into a particular node, or if you're planning to implement a custom scheduler yourself, you can learn all about it on this page. But essentially, it just decides where stuff goes. So the scheduler is going to see, let's say that we were looking at this node, and the kubelet's like, I have I have a job to just run these containers, and then you have a pod go down, right? A container is messed up, or it needs to scale out and it needs to create a new one. So it'll communicate over the proxy to the Kubernetes API, and then the API will obviously is how we're communicating with the controller, and the controller is going to say, I need to make another one because that is my job is to make sure that desired state is as close to current state. And so the scheduler is going to, it's going to, another pod is going to get created, and the scheduler is going to go, okay, I will tell you where this pod is going to go. It's going to go on node 2, and then it'll go there, and then the kubelet can go ahead and be like, okay, got it, I got a work order, and then it's going to just run everything on that node. So that's essentially how the scheduler works. And then, what we're left with now is the etcd. So etcd, if you just look at the actual etcd.io page, it's just a basic description. It's a consistent distributed key value store that provides a reliable way to store data, right? And you can do that across a distributed system, a cluster, or whatever. And it handles gracefully leader elections during network partitions and can tolerate machine failure even in the leader node. So what it means by leader is that like at some point you'll have something promoted to be a leader, and then at that point, that's like the primary, right? And so um, etcd can handle all that as far as storage goes. So that is pretty much it for a little bit more of a deep dive on these components. Just want you, it's not a deep dive, but I want you to understand what these things are. And I want to understand what these things are better before we go into actually building this. So the only thing left to do now is to go over the Kubernetes API. I was going to make a separate section on this, but because I don't want to get too far in the weeds, I'll just go ahead and cover that now. And that's the core of the control plane is the API server, and it exposes an HTTP API that lets you or different parts of your cluster or whatever communicate with one another. It's like the switchboard operator, right? So the API lets you query, manipulate the state of API objects in Kubernetes so you can change the pods, the namespaces, maps, whatever. Most operations can be performed through the kube-control command line interface, or kubeadm if you're using that. But you can also do it directly using REST calls. So you can look at the different client libraries. So if you're writing an application and you want to use the Kubernetes API, there's some different client libraries. So here's a Python, there's one in Go, whatever you want to use, .NET. And these are the officially supported. And then there's some community maintained libraries as well if you want to do Node or PHP for some god awful reason. So that is the basics of the API. So if you have any questions, let me know. And if not, then we'll go ahead and get started with a learning environment and look at doing an installation on a Windows machine to get started.